In this video, we'll be looking at how to go about finding the values for y for a linear equation with a given set of values for x. We'll look at plotting the graph for a linear equation, and we'll look at creating an equation from the line on a graph. Here, we'll be using graphs with an x and y axis. The x-axis goes from left to right, and the y-axis from bottom to top. On the grid are 4 points. See if you can write down what the coordinates for each point are. Remember, the x-coordinate comes first, followed by the y-coordinate. Pause the video now, and I'll come back with the answers. So for the point of A, you should have had 3, 4. For B, you should have -5, 2. For C, you should have -4, -1. And for D, you should have 1, -5. In each of these, we've mentioned the x-coordinate before the y-coordinate, and that's quite important as we go through this video. Now, we've also been given these equations, which only include the y or the x variable. When you see an equation like this, you'll know that it means the line is either horizontal or vertical. So firstly, we've got this line here, which is the y equals 1 line, because it goes through 1 on the y-axis. Here, lower down, we've got y equals -4 because it goes through the -4 of the y-axis. Now we have these. This one to the left goes through the x-axis at -2, and this one to the right goes through the x-axis at 5. Next, we're going to look at linear equations with both the x and the y variable, and what the different parts of that mean. In its simplest form, a linear equation always takes this form, y equals mx plus or minus c. It doesn't need to be laid out in this order, but it can always be rearranged to make it look like this. This is what's called a linear equation. The power of x is always 1, meaning it will create a straight line on a graph, as the increase is constant. As the power is 1, we don't write it, but the absence of the power means we can assume that it's correct. The value of m stands for the gradient, or the change in y with each increase of x. We always look at these graphs from left to right, as this is the direction the x-axis takes, which is what's called the independent variable, whereas the y is the variable that's dependent on what we do with x. The c value in the equation is where the graph or line crossed the y-axis, so we call it the y-intercept, as the y-axis is also where x equals 0. And we'll look at how that works in just a moment. Here, we've been supplied with a grid and an equation. In order to create the graph, or the line for this equation, first of all, we need to write out the grid following all the values of x that we're going to use. These are often displayed in the question, and I'm going to use from -2 to 3 for the values of x, and I've placed those in the grid. Next, we need to calculate the values of y. We'll always start with the x value of 0, and I'll show you why. When substituting the value for 0 in x, it makes the equation very simple. So here we have y equals 2 times x, which we're going to substitute in for 0, minus 1. 2 times 0 is 0, take away 1 would leave us with -1, so our y value is -1. Now I've circled this because if we have a look at the original equation, the y-intercept was -1. The y-axis is where x equals 0. So we can see how those two match up. Now, let's substitute in the value of 1 for x. Here we have y equals 2 times 1 minus 1. We'll do the multiplication first. 2 times 1 would give us 2. Take away 1 would give us 1. So when x is 1, our y value is 1. And if we look, the increase between the 0 value for x and the value of 1 for x is from -1 to 1. It increases by 2. And if we look at our original equation, the coefficient of x is 2. If we were to do this for each one, and we could do, we would find that every single one would increase by 2 because of the coefficient of x. So we can go up 3, 5, and if we draw this constant increase in, we could also backtrack and go back to when x is -1, the y value would be -3, and when the x value is -2, the y value would be -5. So now we have the full range of coordinates for this line or graph. We can now plot these on the graph. We'll start with x is minus 2, y is minus 5. X is minus 1, y is minus 3. 0, minus 1, 1, 1, 2, 3, 3, 5. Which means the line that this creates will be straight, and we can see that here. In this next problem, I'd like you to plot the graph for y equals half x plus 1 for the values of x from negative 2 up to 2. Pause the video here, press play when you want the answer. You might want some graph paper for this. Make sure you set out the grids in the same fashion as I have, as this will help you with the scaling of your graph. So you've got your grid laid out with all the x values in and the y values now to be calculated. As before, we always start with the x value of 0 because we know that that value is going to be the c part of our equation, or the y-intercept. In this one, it's positive 1, so we can put that in here. We know that as we go up this grid, they will increase by the coefficient of x. In this case, it's a half, or 0.5. So we go from 1 up to 1.5 and then up to 2. This is consistent all the way across the grid, so we can now map them backwards and go down by a half to 0.5 and to 0. So now you have all of your coordinates for x and y. We can now plot them on the grid. Now it's difficult to plot the halves in, so I'm only going to do when x is minus 2, when x is 0, and when x is 2. So I plot those on here, and now when I put the line in, you can see when x is minus 1, you end up with 0.5, and when x is 1, you end up with 1.5. So that's how you would draw the graph for y equals half x plus 1. So in this problem, I'd like you to plot the graph of y equals negative 2x plus 5 for the values of x from negative 2 to 2. Press pause on the video and I'll come back and show you the answer. There's something quite different about this graph that I hope you'll spot. So here, the value of 0 for x we know is going to be the y-intercept, which will be positive 5. Because if we substituted 0 in for x, we would just end up with a positive 5. Now the coefficient that's next to x in this equation is negative 2. That means it goes down by 2 as we move up the grid. So when our x value is 1, our y value will be positive 3. When our x value is 2, our y value will be positive 1. Our y value is going down each time. Now that means when we go to the x value of negative 1, it's going to be 7 because it's going to increase going that way. And the x value for minus 2 will give us a y value of 9. We can then plot these all on the grid. X is minus 2, y is 9. X is minus 1, y is 7. X is 0, y is 5. X is 1, y is 3. X is 2, y is 1. So as we read this graph from left to right, you can see that it slopes down because the gradient is negative. In this one, the equation isn't written in the same form we've been used to. We can rearrange it to have it look more like y equals mx plus or minus c, or you can calculate all of the y values with x from minus 2 up to 2. Before you draw the graph, lay it out like I have, as that will be the easiest way to display the axes. Having done that, you'll notice that the gradient is negative because of the negative 4, which is the coefficient of x. If you still started off with 0 as the first value of x, when you do your calculations, you'll notice that the y value is 6. Because it's a negative gradient, it will go down by 4 each time, so the next value will be 2, the next value negative 2, and if we go to the other side, to the left-hand side of the 0, we'd end up with the y value of 10 and 14. We can then plot these points onto the grid and then draw the line like this. Here, we're going to plot the graph for the equation x plus y equals 5 for all the values of x from minus 2 up to 2. You may wish to rearrange the equation, but you can complete it by substituting and rearranging as we've shown you in the previous videos. Again, lay out your graph in the same fashion as I have to make it easier for you to complete. Press pause and I'll come back with the answer in just a second. So here, we're going to rearrange the equation where we're going to move x to the right-hand side. We're going to do that by subtracting x from each side, and we end up with y equals 5 minus x. Now we can say that the value of y when x is 0 is going to be 5, because if we were to substitute in the 0 for x, that would be the answer that we'd get for y, and we can put that in here. We can also see that that is our y-intercept for this equation. Now the gradient here, there doesn't seem to be a number that's next to the x, but we've always got to remember that the coefficient of a variable, if we don't see one there, we assume that it's 1. So here, because it's a negative x, it's going to be a negative 1. So the value of y when x is 1 is going to be a reduction of 1. So it goes down by 1 to make 4. And again, it goes down by another 1 to make 3. And if we look at the values of y when x is minus 1, we can go up to 6 and 7. We can then plot those on the grid, where x equals minus 2, y equals 7, where x equals minus 1, y equals 6, x equals 0, y equals 5, x equals 1, y equals 4, and lastly where x equals 2, y equals 3. We can then draw the line like this, which will go through all the points and be a straight line. Next, we want to look at finding the equation of a line from the graph. Here we have a graph. Initially, I would suggest drawing the grid and adding the coordinates as we've done before, so you can find the y-intercept and the gradient. Don't forget that linear equations, which we know it is as the graph is a straight line, come in the form of y equals mx plus or minus c. I'll show you the answer after you press play on the video. If you press pause now, and I'll come back and show you. So here, we know it comes in the form of y equals mx plus c. We need to calculate what our m is, our gradient of the line. The way we can find that is by drawing this triangle on here. Now I'm going to start here at the y-intercept. We'll come back to that in just a second. I'm going to draw 1 unit across to the right. So that's our x increase of 1. Now I need to go up to the line so it shows us it's going to be positive, and we go up by 2. Now the way we tend to write this is as I've written here, y equals, that triangle means the change in y over the change in x. It's a delta symbol. So the change in y is positive 2 and the change in x is 1. So we know that our gradient is 2 divided by 1, which gives us 2. So we now need to know what the y-intercept is. Well, that's quite easy to spot because we can actually look at where does the graph cross the y-axis. And it crosses the y-axis at positive 1. So we can write the equation y equals 2x plus 1. Now what we can do to double check that is we can actually draw the numbers from our line into the grid and then see if it matches with our equation. So we can put for negative 3x, y is going to be negative 5. For negative 2x, y is going to be negative 3. For negative 1, y will be negative 1. For 0, y will be 1. For 1, y would be 3. And for 2, y would be 5. Now, does it match our y-intercept? Well, yes, because our value of x is 0, y equals positive 1. They match. Does it go up by 2? Yes, it does. That's our coefficient for x, and in fact, our gradient or m value. So we know we've got the right equation for this line. So now see if you can find the equation from the line on this graph. Hopefully you'll have noticed that it's a negative, so it should help you to estimate what your answer for the gradient is going to be. Press pause now and play when you want to reveal the answer. So here we know it's going to take the form of y equals mx plus or minus c. Let's work out our gradient first, and we know that's going to be the change in y over the change in x. Let's take this coordinate here, where x is minus 1 and y equals 1. Let's draw a line across for 1 increase of x. Now we're going down to get to the graph, so we know that our gradient is going to be negative. And if we count down, it's 1, 2, 3, negative 3. So we know that our change in y will be minus 3, and our change in x will be 1. Minus 3 divided by 1 would give us negative 3. So we know what our m value is, our gradient of our line. Now we just need to be able to spot what the y-intercept is, and we can see that the line crosses the y-axis at minus 2. so we can put that in our equation as well. So now we have y equals negative 3x minus 2. We can draw our numbers into our grid to double check this. So let's go from minus 2 to 1, because that's where our line runs from. Our value for 0 is minus 2. So when x is 0, y is minus 2, and we can see that that's the y-intercept on our line and on our graph. As it's going down, we're going to decrease by 3, and we have 1, negative 5, which we can also see from our graph. And if we do the other two values as well, we'll increase by 3 and do 1 and 4. So the equation for our line is y equals negative 3x minus 2. So through this video, we looked at solving linear equations for all the given values of x. We plotted the graphs of these linear equations, and we also wrote the equations of the lines from the graph. In the next video, we'll be looking at quadratic equations, which have an x variable with a power of 2. I'll see you then.